Hello ladies and gentlemen, today our work today is dealing with writing functions, writing equations from situations. Now again, if you need to stop the video at any point, please do so. Some of this and some of the notes that you're going to do today, you're going to actually need to do on your own. So they're not going to be exactly like mine. You'll see why here in a few minutes. So kind of look to see what you've got for your notes, and there's a few things you're going to have to do on your own. So start off with situations. Okay, so if we want to write an equation from the situation, there's some things we need to know. We need to know the what, the rate, as in the rate of change, and the initial amount. In other words, that initial value, that constant. As long as we know what that is, you can write the equation of any situation. So we're going to start with one here. As we look at this, you have a graph, all right, with a certain set of points on here. The first thing is the what. So that's what are my two labels here? In other words, what are we talking about here? Well, we're talking about the number of months. We're talking the balance remaining. Remaining, we don't know. It doesn't really matter right now. But you have some type of a balance, and you're trying to pay off something, right, in a certain number of months. So, number of months and the balance remaining. As we look at this, your number of months is your independent variable, your x-coordinate, so your domain. The balance remaining is your dependent variable, your range, all right, or your y-coordinate. Okay? So, what is my starting amount? Anytime you're looking at this, you want the starting amount, the initial value, is always going to be on your y-axis. All right? Your initial value is going to be on your y-axis. So as we look over here, that's basically starting at 0 months. So as we look at that, it starts way up there, and that's at 550. And what do we call that? Owed or paid? Well, it's what you owe, because it's the balance remaining. So it's how much you owe. Now, how much is being paid off each time? Well, that's when you go through, and if you want to, you can actually make a table out of it. And each time you go through, at 0, start at 550. At 1, after 1 month, you go down to 450. 2 months, 350, so on and so forth. Well, each time, it's decreasing by 100. The x value is increasing by 1. So if we're looking for how much is being paid each time, negative 100 over 1, which is 100. So it's decreasing each time by $100, or 100 whatever. Okay? That's the basic idea. What we know now is we know the initial value, and we know what it's decreasing by, the rate, and that is your rate of change. When you look at this, we've talked about this already. The equation for a linear function, y equals mx plus b. M is your rate of change, b is your initial value. Well, what I did is I plugged in a situation. It says write a situation. Well, this is my situation for this. You don't have to write down the same one. This is the same basic idea. So you look at it. Myself, I bought an iPad for $550. Each month, I paid off $100 onto that iPod. So that's, how many months did it take to pay off? Well, 7. How do you know it's paid off? It's at 0. The balance is at 0. This is the point 70. The y-coordinate is 0, so that means everything's been paid off. Now, if we want to write an equation for this, you need to be able to figure out m and b. Well, m in this case, that was the rate of change. Well, it decreased by 100. Right? The initial value is where it started. Well, it started at 550. You can see that just by looking up here. So the equation ends up being y is equal to negative 100x plus 550. It's negative 100 because we are decreasing. We're going down. All right. Next one. So, using some of the words discussed in the previous slides, all right, we're going to do what we call the piece method. We're basically putting this together. We're going to find the different pieces and then put this together. Write a situation to fit the table below. So, first thing is, when writing an equation or line, you need to know the slope and the y-intercept. So, we have number of sandwiches and the total cost. You can write a situation dealing with that here in a couple minutes. The first thing we need to find that rate of change. When we look at this, when we talk about number of sandwiches and total cost, you need to know which one's your X and which one's your Y. Well, your dependent variable is almost always total cost. It's what you want to know at the end. So you're going to see it when they write these horizontally. Your Y coordinate is going to be on the bottom. What you need to know first is the number of sandwiches. So from here, we figure out the rate of change for Y. Your change in Y. Right? So when we look for that change in Y, from 6 to 750, well, that's $1.50. Right? From 750 to 1050, that's $3. From 1050 to 15, well, that gives you $4.50. Okay? You can do all of them if you want. If we look here, 2 to 3 is 1, 3 to 5 is 2, 5 to 8 is 3. This is your change in X. Well, for each one of these, if you divide 150 by 1, you're going to get 1.5. You divide 3 by 2, you're going to get 1.5. And if you divide 450 by 3, you're going to get 1.5. Is this a constant rate of change? You bet. Constant rate of change of $1.50. So your value of M, if you want to write just 1.5, you can. If you want to write $1.50, write $1.50. Now, the other part is finding the value of B, your constant. And that's where we had to plug in. That's what that process column is for. If you're not given a process column, make your own. Go off to the side. We can do it over here. The value of X, so MX plus B. Your rate of change is $1.50, so 1.5 times the value of X, which is a 2. Well, $1.50 times 2 is 3. Plus what number gives me $6? Well, 3. So your constant should be 3. I'll try another one. 1.5 times 3. Right? 1.5 times 3 gives you 450. 450 plus 3 gives you 750. Alright? So your constant is going to be 3. What you're adding on, the initial value, what you start with. So the equation, written in slope-intercept form, that y equals mx plus b, we got y is equal to rate of change, which is 1.5 times x, plus your constant, 3. Alright? Alright. So, from this, I want you guys to write a situation dealing with number of sandwiches and the total cost. So think about it. How much per sandwich, and what does he pay to begin with? Does he buy something else with that? What else would you buy with a sandwich? All right, that might be $3. Think about that. All right? Maybe you bought a drink and a bag of chips. They cost $3. Think of something like that when you write this situation. All right, so let's look at another one. So you're going to write a situation to fit this one. Well, first thing we're going to find is we're going to find the equation. Now, as you look at this, there's a few ways we can do this. If you want to make a full table with the process column, I have no problem with that whatsoever. If you like that process column in there, put it in there. Do it off to the side somewhere. You're more than welcome. If you only like just the regular T-chart, do so. But when you look at this, you're going to need a few points on this line. Well, one of the points that you guys should always look for is the one on the y-axis. The one on the y-axis is where x is going to be 0. Well, that's going to be 0.50. And we've talked about this point before. Wherever the x-coordinate is 0, the y-coordinate is your initial value, what you start with. Because you haven't done anything yet. You started at 0. So that's your initial value. Now, from there, we got a couple more points. One at 145. You got another one at 240. All right? 335. All right? Those are plenty of points to be able to find your rate of change. And as you notice, for your rate of change, you're changing your value of y, -5, -5, -5. You're changing x, 1, 1, 1. So as we look at this, you're changing y divided by your change in x, which is your rate of change, is -5 over 1, which gives you -5. So if we have to write the equation of this line, again, y equals mx plus b. Y is equal to m, which is your rate of change, -5, that is your coefficient, all right, times x plus your initial value, your constant, 50. All right. So for this, I want you to write a situation that deals with the number of weeks and with the balance remaining, where it goes down, but it starts at 50, all right, $50, 50 cents, 50 whatever, all right, and then decreases by 5 each time. That's what the -5 tells you. It's decreasing by 5 each time. You write that situation, anything you want. All right, so we have another one here. Write a situation that fits this equation below. So at this point, we got y is equal to 4x. Well, what you need to come up with, a couple things. First, the rate of change. Rate of change, as we look at this, we look at the equation for a linear function. Rate of change in this case is whatever your coefficient is, the number in front of that value of x, so 4. The next thing you need is your constant. Remember, your constant is your initial value. It's whatever's being added on. Well, if you notice here, nothing's being added on. And think to yourself, what number represents nothing? Well, that's 0. So you have a constant of 0. All right. So I want you to be able to write a situation dealing with something that starts off at 0. So you didn't start with anything. And then you added 4 to it each time. Maybe it's number of books read in a month. Right? Maybe it's number of tickets you buy each week to go to a certain place. Maybe it's how much you pay for a sandwich each day. Right? Those are all different ideas of how you would add on 4 each time, starting at 0. Right? I want to see some of those examples on Friday. All right. Next one. Here, what we're doing is we're going to look at this situation. We're going to write the rate of change, the initial value, and then we're going to write the rule. Whenever you see the word rule, all that means is writing the function, the equation. That's all it is. We call it a function rule. So, rate of change. Change in y, 850 to 11 is 3. 1150 to 1450 is 3. You can figure out the next one. We'll figure out that one here in a second. Okay? Change in x, going up by 2 each time. So if this one goes up by 2, then this one has to go up by the same amount over here, which is 3. So it's 1750. Okay? So what we need to know is the function. So you need to know the rate of change, so the change in y divided by the change in x, which is 3 divided by 2. If you want to write it as a decimal, because we have decimals here, you can, which gives you 1.5. The initial value, well, again, we're not given a process column. So if you want to create your own, when we do this, mx plus b, we're going to take the rate of change, which is 1.5, times the value of x, plus some number has to give you 850. Right? So, when we look at this, So, as we look at this, 1.5 times 10, all right, that's $15. To get to 850, what do you have to subtract? What do you subtract from that? So, you end up with $15. 15 minus some number has to give me 850. So think about that. When you do it, you'll end up with a negative 6.5, right? Or 650. Right? If you do the next one, 1.5 times 12. Right? When you multiply that out, 1.5 times 12 should give you $18. 18 minus what gives me $11.50? Again, $6.50. So your initial value is negative 6.5. So the rule for this one, again, y equals mx plus b. Y is equal to the rate of change, which is m, your coefficient, times x, plus your constant, which is now negative 6.5. All right, that's an important problem. You might see that sometime in the future. Just a little hint. I'd remember this one. All right, and then we're going to go through another example of patterns. And hopefully we're on the right track with this, because you're going to see something like this again too. So it says, which rule relates to D, the number of dark tiles, to W, the number of white tiles? So as you look at this, this is number of dark tiles, number of white tiles. So as we look at this, figure 1 has 1 dark tile. Figure 2 has 2. Figure 3 has 3. You can probably guess what figure 4 would have. You can keep going. So we have 2 here, 4 in figure 2 for white tiles. You got 6 in figure 3. And as you can tell by your rate of change, when we go through this, 2 things you need to know to write the equation of a line. The rate of change, m, and then your constant. So you need to know the coefficient and the constant. So find the change in y. 2 to 4 is 2. 4 to 6 is 2. You can probably guess it's going to be an 8. It also gives you 2. Your change in x, real simple, 1, 1, 1. So we want to know for the value of x, so x terms. So as we look at this, your rate of change, your coefficient, change in y over change in x, will be 2 over 1, which is 2. So right now, we've got the rate of change. We still need to find the constant. Again, we don't have a process column here, so you need to create your own. So with mx plus b, that's your process. 2 for the rate of change times the value of x, so 1, plus something has to give you 2. Well, what's 2 times 1? 2. So you don't have to add anything on. All right, if you do it for the next one, 2 times 2 gives you 4. Well, you don't have to add anything on there, so your constant is 0. So if we go to write this, as we look at this, you can tell you can already cross those off because you're not going to add anything on. The key is understanding which one's your domain and which one's your range. Well, your x-coordinate is here. This is your domain, so D has to be in the function. This is your range, your dependent variable, so that has to be the answer you're trying to find. So when you're writing this function, as we look at this, the first thing we do is we start with the dependent variable, which is your y. So we write with the w. And then times the rate of change times d. We don't write anything on the end because the constant is 0. So your answer to this problem is A. You have to know the difference between your dependent and independent variable to be able to get this problem. It's very important that you remember that. All right. Again, on Friday, come in with any questions. If you need to rewind or look at anything else, do so. But I want you guys to have a good evening. I'll see you on Friday. Goodbye, guys.